ready. So the mandatory slide about myself, maybe I can cut it short since I got already a presentation from Edo. As he was saying, head of platforms means that I'm the lead of the platform team. We basically are a group of 8 people that try to help our fellow developers in the company. So we build tools and best practices and stuff like that. Those are my handles. I'm no longer active on Twitter. You can find me in Mastodon there. It's a specific instance for PHP community, so you can sign up if you want, and you just have to say, I'm a PHP developer, and you get accepted in. And I'm also one of the user group coordinator, PHP user group coordinator in Milan, and one of the PHP Fig secretaries. And for both those roles, we try to be 3 of us so that we share the load. And right now we are down to 2. So if you want to help us both locally in Milan or globally with PHP Fig, step up, talk to me, reach out, write me an email, whatever. It's basically there's no barrier of entry, and it's a good way to help the community. So, for the topic of today, I've tried to tell you a story. I got the idea for this talk because I was thinking about that in 2 weeks from now, it will be 10 years that I'm at the same company. I'm at Facile. And looking back, obviously, I've seen a lot of things, good and bad. I've seen stuff going really bad due to poor choices, technical choices, or people choices. But I think that the most powerful thing was that I was able to see the consequences of my choices, of my technical choices, and so I could judge if those were good choices or bad choices. And looking back, I've noticed that there was a common thread, a common topic that started even when I just joined the company. And that basically was that I was working basically on a simple PHP application. It was the classical LAMP stack. It was Symfony 2. It was kind of simple but big. I think it reached more than 1 million lines of code today. And at the time, we were on bare metal. So no virtual machines, just literal physical servers. And we even didn't have a dedicated sysadmin. We were relying on people that another company was lending to us. And so we couldn't ask so much to them. They knew their stuff, but in particular, we wanted to use a queue. And why we wanted to use a queue? Because our application needed to do long elaborations, like working on PDFs and joining them, and we wanted to push that into the background, avoiding doing long stuff inside our controllers, inside our requests. Or we wanted to postpone stuff, something like the user is asking for this, but I want to execute this in 15 minutes from now. And that was dynamic, so a cron job couldn't cut it. Or we just wanted to avoid calling other services live directly from the controller. And that mainly because it was eating our reliability, our response time. And that may seem something trivial, but if you think about it, if you have a controller that calls another API server, which maybe calls another API server, which calls a database, it's 4 hops. And when you try to calculate the reliability of this, well, let's say that you're aiming to 99.9% of uptime. Okay, it's 3 nines, not 4 because we are not Google, but it's still a good target. And basically, 99.9 means that inside a month, you're not working, you're down for nearly 43 minutes. It's not a little amount, and it's still the target. It's not the optimal. But when you do something like that, when you have a controller that calls another controller that calls a database and so on and so forth, the reliability of the whole system is the multiplication of the reliability of each hop. So 99.9 at the fourth, it's 99.6. It seems high, but it's not. Still, in a month, 99.6 is nearly 3 hours of downtime. I think that if you're down for 3 hours, your users aren't probably happy. So just being able to say, okay, I know that I have to do this, but I can say to the user, okay, we are taking care of that, and I can push it to the background, and a queue can do that for me is a good step. It's a good way to make your application more resilient and handle failures and stuff like that. As I said, we didn't have our own sysadmins, and so we asked them to have a queue, and they said, we don't know any system that we can give you, and so that will take months for us to study, understand, and deploy to the production, and so we got shut down. And so, since, as I said, we were on a classic LAMP stack, what we did was, let's use our dear old MySQL server. Probably someone here did the same. And so, just a dedicated table, each row is a job, it's something that we wanted to do, and we added a column to act as a lock, because basically we wanted to have multiple processes in the background consuming this table, and so each process had to say, okay, this job is mine, nobody else should touch it, to avoid doing a job more than once. And normally when you do something like this, you do a select for update query. That just means that it's a select that at the same time, atomically, requires a lock on the row. So afterwards, I can put a value on the lock column and say, this is mine. Normally, you put like a timestamp. So to say, in this moment, I got it, it's mine, nobody should touch it. And that worked, but at a cost. Basically, every day, our replica nodes in MySQL got 2 hours of delay. And that wasn't good, especially because it was a single cluster and everybody in the company was using that. And so they weren't happy about it. And this was a gentle push for our CTO about the matter, which in turn did a gentle push to the side admin. And in a couple of months, we got a real queue. Yay. I applauded my team lead when he did this. He kind of did it on purpose. And it worked, but I don't suggest this strategy to do it. At the same time, though, it was still 9 years ago. So PHP 5.4, 5.6 got out that summer. We weren't even up to date. And the extension that it's required to talk to Rabbit wasn't perfect. It had bugs. And even the fact that we are in PHP is a limitation for this kind of work, because we are single-threaded. And so basically you say, okay, Rabbit, give me a message, something to do. You start working on it, but while you are doing something, you cannot talk to Rabbit. PHP cannot interrupt your work. And what often happened was that Rabbit was giving us a timeout. And when that happens, Rabbit thinks that your consumer is crashed. And so it takes the message and it redispatches it immediately to another consumer. So we were, again, hitting the issue of having a job that is worked on twice. There weren't many bundles or libraries to do this kind of stuff on the old Sun bundle. Don't worry. And so at the end, we decided we should write our own. We should write our own implementation of the queue. And we did it. It worked. And we even maintained the MySQL implementation on the side, both for slowly migrating toward a real queue and to have a way to park our failed message, for example, or to park stuff that, okay, I want to do that, but in 2 hours from now. So instead of filling up Rabbit, we did it in like this. And all was fine for a couple of years. A couple of years later, it was probably 2017, I got promoted to team lead. I got assigned to a new project, and I chose to use MongoDB for whatever reason for that specific project. And in the meantime, we didn't have enough time to extract what we did as a library. So at the end, I just decided to copy and paste my code, do some modifications, because in this project I wasn't using Doctrine anymore, and all was fine again. I had a working queue for me, but still a custom implementation. Couple of years goes by again, and in 2019 I went to SymfonyCon. And it was my first talk outside of Italy. I was excited. Everything went great. And on the second evening, I got to this talk. You are probably unable to recognize the speaker from here, but you know him. He's Ryan again. You probably have seen this tweet from a couple of months ago. Michel cited him in his opening keynote. And I hope Bruce will forgive me, but we want just one swear word. We'll just keep PG rating, but fuck cancer. He's really a great guy. He's someone that was here when Composer was born and was giving suggestion to the authors. He's the author of I don't know how many lines of code inside the Symfony packages, and he's even so involved and so able to transmit the excitement when he speaks. You probably listen to him often because he's the main guy behind SymfonyCast. And even after that, that wasn't the only reason that his talk stuck with me. The point for me was that in that conference, they were releasing Symfony 4.4. Fabien even did the release live on stage during the opening keynote. It was incredible to witness that. But you can guess that the talk was about Symfony Messenger. That was because in 4.4, the component became official and supported. It exited the experimental phase. And so Ryan Talks was about all the features of the component. And the thing that stuck with me is that while he was going through all the features of the component, every feature was identical to what we did in our custom implementation or was something additional that I needed. That wasn't a coincidence. Obviously, it was because we both, us and the Symfony team, followed best practices or good approaches when working with the queue. But the end line for me was I was able to go back to my project and delete everything and put Symfony Messenger in. And a couple of months later, I did this. And obviously, I do not suggest you to do everything with a single merge request like I did, but present me was really happy that past me did it, because so that was really easy to pull out this screenshot. As you can see, for every line of code that I had to touch, I could delete another one. And I had to touch a lot of code just because I had to put the Symfony Messenger way of code in my code, and I had to touch a lot of tests because I had to use the Symfony Messenger services to check and do my assertion of what was happening in my code. Last piece of my story, a couple of months later, since our company is focusing both on PHP and Node, another team needed to do the same stuff that Symfony Messenger does with the queue, but in Node. And I discovered that there isn't an equivalent of Symfony Messenger in the JS world. So keep in mind that we are lucky having this kind of libraries available to us. OK, end of the story. From now on, just code, just example, just things that you can do. Obviously, the start is installing Symfony Messenger. Okay, so you get the package, and if you are using a Symfony common framework application, and if you are using Symfony Flex, you'll got the default implementation and the default configuration out of the box. This is the default configuration, and as you can see, it's just under the framework key, under the common Symfony configuration. And the main thing that Messenger reasons about is transports. It's just a way to say, OK, I have this queue and this other one. And you have to say what kind of underlying technology you are using with each transport. The most basic one is the sync one. Obviously, the key is the name of the transport, while instead the string is the DSN, the description of how I connect to it. But the sync one is not so useful. Basically, it's the same as using the Symfony event dispatcher. The real one, for example, in here, I'm just using an environment variable, so I can inject the configuration outside, and I can even describe and use the doctrine connection to have another transport in the same way as I did with MySQL with the old implementation. This is called failed because I can define a failure transport, so a way to park failed messages. That was one of the features that we did and I could find already out of the box. And you can define routing, so you can say which message goes where. You also get a suggestion for your test environment, so basically it suggests that you should have the same configuration but use an in-memory implementation of the transport, so you don't have to pull up a Docker container with Rabbit or whatever you need just to run your tests. Out of the box, you get a lot of drivers for the transports. This is the one that I'm using with Rabbit. This is the other one that just reuses your DBL connection, so you can write messages on a database. I even write my own. As I said, in that project with MongoDB, I wasn't using Doctrine, so I had to write my transport, but it was something like 200 lines of code tops, everything, and it helped a lot to understand how it works under the hood. There are many, many more available, and you can even reuse the drivers from the old NQ library. There's this adapter that allows you to reuse those. So you have many options to use any kind of queue that you can think of. But how Messenger works is pretty straightforward. So a message for the Symfony Messenger component is just a class. So the only thing that you have to keep in mind is that this class has to be serialized. So it's better if it just contains properties with scalar values. And in this case, I'm thinking about compress image. So the job that I want to do is compress an image that I have parked somewhere, and I have an ID that helps me fetch the image from wherever it is. When you want to dispatch this message, in this example, this is a controller, okay? You have to inject the message bus interface, which represents basically the component inside your DI container. And the only method that you need is this dispatch one, message bus dispatch, and then the message that you want to send to the queue. On the other side, if you want to work on this message, you have to create a class that acts as a handler. So it receives the message, and you do something about it. First, you have to use the attribute. Okay, beforehand, before attributes, there was an interface, but it's deprecated now, obviously, in favor of the attribute, but it's still the same. Just says to Symfony, this is a handler, and you have to implement an invoke method with a single argument. And the type of the argument tells Symfony which kind of message I can handle. So it's a common practice to just take the message and, for example, use a doctrine repository to fetch the entity that you want to work on from the database. And if you cannot find it, just fail. So if you let an exception blow up your method, your invoke method, Messenger will consider this job as failed and act accordingly. In this example, I'm using a specific exception, the unrecoverable message handling exception that comes from Messenger. If you throw that specific exception or something that extends that, you're saying do not retry it because it's something that it will not change. If I didn't find the entity in the database, I don't think it will pop up later. It doesn't exist. Someone deleted it. If you want to run this code to execute this, you just have to use this specific command from Messenger, Messenger consume, the name of the transport that you want to consume, and I suggest you to use -vv, which is verbose, because at that level of verbose, you will get a line of log even if the consumption went well. And so it's showing that if there is some activity, the consumer is working on something. And that is all. This is everything that you need to do, and you already have working code. You don't have to do anything else. So from now on, I will try to tell you about some advanced features and way that I use these in my projects. The first thing that you have to understand when you look deeper into the component is that they really went with the metaphor. And so the message is wrapped into an envelope, which is just a class that the messenger uses to type in and let you go run wild with any kind of class that you want to use as a message. So the envelope even has stamps. You can think of stamps like headers, so a way to attach more information to the envelope. The serializer stamp, for example, it's a way to pass more information, more configuration to the serializer when works on the message. And you can pass the envelope to the dispatch message, method, because it will not care. Basically, if dispatch says it gets an envelope, it will treat it like it. Otherwise, everything else, every other kind of object is a message. And so it will put itself, the envelope, around your message. You can also put stamps like this. So you dispatch your message and then pass as a second argument an array of stamps. And this is another very useful stamp, the delay stamp. I'm telling, in this case, to Messenger that I want to work on this in 3 seconds from now. This is milliseconds. As I already told you, there are even retries. This is another feature that we implemented manually, and it's really useful. In this example, I exploded the configuration. So if I use the name of the transport and put a string, this is the DSN. If I explode it, I have to indicate the DSN like this. And this is the key for the retry strategy. So how I do configure how much retries I want, when, and so on and so forth. These are the default configuration values. So by default, Messenger will retry 3 times the message. And this is useful because, for example, if your message is calling an external API and you have just a small network hiccup, it will retry immediately, and it probably goes through, and you're fine. You will never even notice it. And by default, it will wait 1 second, still milliseconds here, between retries. Because obviously, if it went wrong, you do not want to retry immediately. You want to basically put the message at the end of the queue and try on working on something else in the meantime. So if the message is the problem and not the service that you're calling, in the meantime, you will work on more stuff. Another great feature is that even the delay is dynamic. It will apply what you should call an exponential backoff, basically. So the first time, it will retry after 1 second, but then it will start using a multiplier. So second time, 2 seconds, third time, 4 seconds, 8 seconds, and so on and so forth. And you can put a cap on the delay. With 0, there's no cap. You can put, I don't know, maybe 60, so the maximum delay will be 60 seconds. This is really useful because if it wasn't a network hiccup, for example, but the service is overloaded, insisting every second will make it worse, obviously. And so using larger delays will give time to the server to maybe recover from its overloading situation and then answer correctly to you. If this is not enough, you can even define a custom strategy for the retries. You just have to define a service that uses the retry strategy interface. So you can write your own custom logic. For example, okay, by default, use the default strategy, but if it's a specific message, I want to do something else, or something like that. I was talking before about the fail transport, another feature that we implemented. So basically, what happens if after even all the retries, I'm still failing? In that case, Messenger will park the message in the fail transport. The fail transport is the one declared there in the failure transport key. And once it's there, you can inspect it, you can decide if you want to trash it or retry again manually, whatever. You have multiple commands to do that. So failed show to have a list, failed retry to retry all the messages, or if you put an ID or a list of ID, then multiple messages. Or I think if you do not put the list, you get an interactive command. So you can say, okay, do you want to retry this or not? Do you want to retry this or not? And it will ask you what you want to do. You can still use the failed transport as a normal transport and so-called message consume there. It will just try to consume all the message that it can find and wait until it's empty. Or remove, obviously, to delete stuff. This is instead a feature that we didn't have. We were having to manually route messages. Basically, the routing acts as a way to decide in which transport you want to send each message. The part on the left can be just a full qualified name. So it can be an interface, an abstract class, a concrete class, it doesn't matter. You just have to say on which transport you want to go. And Symfony Messenger will go that on a list and stop on the first match. So I've used the asterisk as a catch-all in this case. And this is a real example from a project that I did later. Basically, I was working on a project last year that was sending out emails, and each email had a priority. So I wanted priority 0 emails to go out right away because they were urgent. Everything else could wait. And so I just wrapped the request to send the email in a specific message with a specific priority. And in this way, I was able to route this request and consume that in different ways. But that is not enough. The routing is not enough to do what I just told you. To make it work, I needed to work a bit better with the consumer. So in that specific case, what I did was using the messenger consume command and listing the transport, all the transports like that. But when you do that, it's not a round robin. It will look to the first transport, and if it doesn't get anything to do, it will look to the second. But as soon as it gets something to do, it will reset the cycle. So basically, this means that until the priority 0 queue was empty, it will be stuck there and consume just that queue. But that was exactly what I wanted to do. If you do not have this situation, you have the other one that I had, for example, in the older project, the one with MongoDB, where I had 2 queues and no priority between of them. And in that case, I created 2 different consumers, and I put the transport in reverse. So basically, each consumer was first looking at its queue, assigned queue, and then if it had anything to do, it will start looking to the other queue, basically helping the other one. So if I had an imbalance in the load that I had, so 1 full queue and 1 empty one, I could basically have them help one another and not standing still just because its queue was empty. This is another helpful feature that I did not have in my custom implementation. The consume message command has limits, so you can tell it to just quit gracefully after reaching some limit. You can tell him to wait for a number of messages to be consumed, or a number of failures, or after a fixed amount of time. Those are seconds, so this is an hour. Or the most interesting one, after reaching a memory limit. This is really useful because obviously PHP is not designed to do long-running process. And this is a long-running process. If everything goes well, the only reason that you should shut this down is because you're deploying and you want to reload it. So in this way, I could basically say, okay, if you're reaching the limit, maybe you have a memory leak somewhere or something, you don't know. You can say, okay, finish this message off and then shut it off and then find some way to pull it up again. To do that, I combined this command with a small package that I wrote some time ago, which is just a shell wrapper that runs a command on a loop until you get an error. So if the command exits with an exit code of 0, it will retry it and again and again and again like a daemon. If it gets an exit code different from 0, it will propagate outwards and die with it. This for me was useful because we have our application deployed in production with Docker and Kubernetes. So I already had something that was keeping my process up, but I needed to let the failures go out to the orchestrator to let them know I have a problem and let Kubernetes handle that for me. So basically, my container is defined like this. I have, my wrapper script, PHP. I set manually a memory limit for PHP because obviously my default configuration is not good for a consumer. So PHP FPM is good maybe with half that memory, if even less. And for the consumer, I want to put a limit manually. So being console, message consume, and then a memory limit. You can notice that I'm putting a lower memory limit than the one from PHP because I need some buffer. The limit will kick in and wait for the consumption of a message to consume. So if I hit a limit while I'm still working, that's obviously an issue. So I have some buffer, and when that happened, it was really, really useful because I could see the graph for the memory limit go up and up and up and up and up, and then vertically, basically to 0, because thanks to the shell wrapper, the PHP process got killed, terminated with an exit code of 0, and got up again. And that's a workaround, obviously. The best thing would be to fix the memory leak, but that gave me the time to fix it without having an incident, without having this crashing and crashing and crashing over again. And it's pretty useful because so you don't have any pressure to do that. You can even sleep and think about it tomorrow if you don't have enough time. Obviously, it's not all unicorns and rainbows. I still got some issues, and so I want to talk about it so you can avoid the problems that I had while working with it. The main thing that I didn't like about it is that by default, Messenger will not use the JSON format for the serialization, but it will try to use the PHP serialize format, which is not great. It's not really human readable. You can have some incompatibilities between versions, or even if you want to send a message to another application which is not PHP, obviously is not ideal. So you can tell to Messenger that you want to use JSON for its serializer, and in this case, the Messenger is using its own serializer. It will not use the common one that you can use in the rest of your code. It's still an instance of the Symfony serializer, but it's wrapped in an interface that is specific to Messenger. You can add context if you want. This is still the same configuration for the serializer for Symfony. And you can say, okay, I want this service as a default serializer everywhere. This is obviously the name of the service that the Messenger defines for itself. Or you can tell it to specific transport. When I got to this issue, basically I noticed just later that I had messages with non-JSON serialization inside, and I didn't know how to fix it because I couldn't just deploy this, because if a message was serialized in the old format, it will break, basically, because it was an in-flight message. I would have to, stop my application. That wasn't feasible for me. So to solve this, I had to define my own serializer that wrapped two different serializers, the one in JSON and the one in PHP. And the only thing that serializer did was, when reading, try to deserialize in JSON. If it fails, fall back to the other one. And when writing, use just JSON. So in this way, basically, it was automatically translating the messages that were in flight after I deployed this change. It was a bit tricky, but it's doable. So you don't have to shut down your application to do this translation. Other changes and tricks that you can do is on tests. As I said before, you get the suggestion to use the in-memory transport. So it's just basically a class that puts messages in an array. But I highly suggest you to force this option, the serialize option. This is available, if I'm not mistaken, from 5.2. And it just means that when you're using this, even in test, it will forcibly serialize the messages. And this is useful because sometimes you can put something in a message or use some advanced syntax that can break the serialization. For example, I think that when PHP 8 got out, I started putting read-only everywhere, and that breaks the serialization. And without this, you will not notice if not in production. Obviously, too late. And in this way, when you run your test, this will break your test, and you will notice immediately. When you use this, when you use the in-memory transport, you can obviously get the transport from your container, but you get this getSent method additionally. It's just a way to know which messages were sent out while executing your test. And so it's useful to assert, okay, I got a message out of it, and it's a specific message of that instance. So you can run assertion and check that your code is doing what you expect. In particular, in my test, I tend to use this approach. I have basically an ACK message method that basically does the same as using the message consume command. But I don't want to do that because I would probably have a different functional test that runs on top of the handler to check that it's working correctly. And so I get the transport, I call the same method that the consume command uses, get. I'm using array shift because get can get you more than one message. It depends on the transport. For example, with Rabbit, you can ask for a batch of message, so more than one. And then I call hack. Hack is, okay, I got it, I consumed it successfully, so it's a confirmation to the transport. In this way, I'm telling to Messenger that I consumed it, even I didn't do anything because, as I said, I don't want to work on it, but I consider that consumed and return it for assertion. And then I can assert at the end of each test that there are no pending messages in the queue. You can notice that I didn't do that in the tear down method because I discovered that the tear down method is called too late, after PHP unit already decided what's the outcome of the test. So if you put an assertion in the tear down and it fails, it will consider that as an error, not a failure. May seem something that you can ignore, but it can also break in the execution of your test, and it's not good. Instead, you can extend that assert post condition method, and that's a hook that it's run immediately after the end of your test method. It's really useful. So as you can see, I'm just iterating over all my transport and asserting that I don't get anything if I call the get method. So in this way, if my code by mistake push out a message, I will notice it immediately. Another thing that you have to care about is that the failure transport is still a transport. And this means that by default, it will have a retry strategy. So by default, at the third retry in the failed queue, it will get discarded. I never wanted that, so you either put a very high number in the max retry value, or in my case, I implemented an always retry strategy, which is just the interface with return true. Will always retry, so that was fine for me. Last but not least, Messenger is a great abstraction, as I said, but something leaks out. You have to know what driver you're using below, because obviously do not use the database for real queues with high traffic. Please do not do that, or you get the same result that I get at the start with the frame guy. And because a table is not designed to have high throughput or high contention when trying to lock on the first rows. Another thing that I discovered, SQS, which is the AWS system for queues, has a limit on the delay. So you cannot ask for more than 15 minutes of delay. If you do that, you get a 400, and so an exception inside your code. Another thing, a peculiar thing, is that with RabbitMQ, it does polling, not fetching. This means that at the extension level, it doesn't call fetch, which is a blocking call. So if you call fetch with Rabbit in the extension, it will stop you, and your code will be stopped until you get a message. And maybe during the night it will take hours, and that's not good, obviously. And instead, it does polling. You use the get method, so it just, do you have a message? Do you have a message? Do you have a message? And it gets an immediate response with an empty array, with nothing's there. It works. It's great because that means that if you have to shut it down, it works immediately. It's not stuck. But if, for example, you look at the RabbitMQ dashboard, it will say 0 consumers active. And so you cannot monitor how many consumers are actively working on your queue. But it works, so it's just something that you have to know of. And this is all. Thank you. Please rate my talk and the other talk on Joined-in. Those are my handles and emails and whatever. You can find the slides both on Joined-in and on my site. Thank you.
Thank you. Thank you, Alessandro. Any question here or from home? One question.
Especially for you. Great talk. Thank you very much.
Thank you.
I'm just wondering, what are common use cases for using delays for your messages?
Apart from the retries, obviously. It happened to me, for example, that I had to do something, but when dispatching the message, I didn't flash it to the database yet. And it may happen that you're faster than your database, so maybe even delaying after a second is enough. Yeah, exactly. Okay. Or as I was saying at the start of the talk, maybe you just want to do something later, but that later is too dynamic, so a cron doesn't cut it. It happened a lot in my first project because that is a B2B platform for insurances. And so it happened that we were asking the insurance to do something, and we had to give them time to do that. And so basically, we did an API call, and then we dispatched a message, okay, 15 minutes from now, check that that really happened, for example. And this allows you to do it without having to have something like a cron every minute or something like that. And it's also helpful because under the hood, what happens with something like RabbitMQ is that it defines on the fly a specific queue with it's called a dead letter mechanism that says, okay, everything in this queue stays there for 15 minutes, and then it gets redispatched at the end of the proper queue, and you don't have to do anything. Doing that manually in our custom implementation was kind of tricky, and we had basically to have fixed delays because you have to define the dead letter queue by hand or programmatically. Instead, Symfony does on the fly, and it also deletes them immediately after it's empty. So it's really useful because it does everything for you. Obviously, with other implementation, like the Doctrine one, it just sets a timestamp on a specific column, available at, but still, that's the beauty of the abstraction, and it's still really useful.
Yeah. All right, cool. Thanks, man.
Thank you.
We have other questions here? Okay. You do my job better than me.
Any experience with running Kafka as a backend for these queue systems?
No, I never use it, sorry. Not Kafka.
I do, maybe we can check later. And maybe information about the PostgreSQL.
Okay.
There you have a way that the database is notifying PHP through a trigger. I don't know exactly how it works, but there's something magic happening there. So.
Yeah, I think it's the only case where you can use a database to do something like that. Yeah. I don't know if the Postgres Messenger implementation does that, or it's just more plain. But still, I think that it does that by listening to the streaming of changes of the database, basically. There are many databases that allow you to do this kind of streaming and attach basically on the changelog. And that's probably the only way that you can use to do this kind of stuff, because in that situation you can have, for example, someone that sees through the changes. Okay, I get a new message, you get it, you get it, you get it. Basically, you don't have contention like that, because with the database the problem is the contention. You have multiple processes that try to lock the same first row, And that's what was causing all the issues of in the replicas for us in that start.
Yes, the messenger doctrine component that is defining a trigger in PostgreSQL, and that's
I use as a trigger. Okay,
yes.
I didn't look at the implementation because I'm not using Postgres right now, but okay, interesting.
So we saw that happening. So okay, what's going on there? So that's the trick.
Okay, thank you.
Thank you.
I have a question from home.
Yep.
In one example, there were 2 queues and 2 consumers, but
Yep.
the queues had the same priority. Why not use a single queue then?
I think it was because one queue was getting stuff from the outside of the project, if I'm not mistaken. So basically, I was just consuming, but not writing. And I forgot about it. Basically, to do that, I just wrote a custom serializer for that queue. So basically, I knew the format. It was still JSON, but not coming from Symfony Messenger. And I was able to say, okay, if I get this input, I can remap to a Symfony Messenger object, so a simple PHP class, and I was able to intercept the flow from the outside and work on it. And also, it was useful because since it was running inside Kubernetes, I also added an autoscaler to it. So basically, it's a component that can look inside Rabbit, see how many messages were in the queue, and create more replicas of the consumer as needed. And it's so powerful that I can even scale to 0 when the queue is empty. And since the consumer can get up in like 3 to 5 seconds, I'm saving a lot of computing resources like this.
Okay. Another one. Does Laravel queue system replace this, or they can be used together?
I don't think it replaces it. It's just a different system. This one, obviously, being a Symfony component, can be used in the framework or alone. I have a colleague that used it, for example, on a Zen2/Laminas project without an issue. And the Laravel component is just something that hooks more easily inside the Laravel project. So if you're using a Laravel project, maybe it's better to use that.
Okay, last one. How can I validate the message while consuming it to put it back in the queue?
You just mark it as a failed. So, or that's not the only way that you can do it. Okay, if you throw an exception, as I said, it counts as a failure, and maybe that's enough if you have enough retries. But you can even redispatch it. You can take the message, dispatch it again, return, so the original one is not considered failed, but you have basically in the queue a copy of the original one. You have to keep in mind that the new one will not have the same stamps. So you will lose all the context, all the counting of retries, but if that's what you want to do, it makes sense. You just take the object, dispatch again, and you're gone.
Okay. I have one last
Yes?
second question. Would it be okay to still use the queue with things having delays like 2 weeks old?
2 weeks. So basically you mean...
Example, reminder emails.
You can do it. Depends on, in that case, you have to keep in mind which underlying transport you're using. So as I was saying, RabbitMQ creates a secondary queue, but it creates one for each delay. So if you have 15 minutes, 2 days, 3 weeks, depends on how many kind of delays you create. But Rabbit is very, very good at not consuming so much memory, so it's very, very, very efficient. I think it was wrote by Ericsson 20, 30 years ago in Erlang, and it was used to keep the cell towers running, so it's really, really good for this kind of stuff. The only way to consume the memory of Rabbit is to put very, very big message inside. So if your message is small, that's not an issue. If you're using the database transport, that's good too. It's just a value in a column. I don't know. You have to check with the single implementation.
Okay, thank you. I don't think we have any other questions. So a big round of applause for Alessandro Lai. Thank you.